Okay, so today we are starting our first chapter of mathematics of first year class, that is complex number. But before starting the chapter, we'll be going with basics. For example, number systems, what are real number, rational, irrational, and then we'll be going towards complex number to the main topic. Alright, so initially we will be discussing the number system. Wait. Alright, so this first set of number is natural number. The set of natural numbers. Natural number are basically denoted by capital N, and their set basically starts with 1. 1, 2, 3, and basically so on. So where they are used, now we need to focus on this as well, where these numbers are basically used. These numbers are used for counting. So the natural numbers are used for counting. Alright, now the second set of number we have is whole number. Let me write that too. Let me write this with the same color, or shall I keep? Alright, so second set of number we have is whole number. Set of whole numbers. Alright, which is basically denoted by capital W. And this set starts with 0. 0, 1, 2, 3, and basically so on. So now where they are used, like we know that natural numbers are used for counting. However, here we have only introduced one number, which is 0. So where they are used, are they also used for counting? Yes, of course they are used for counting, but there is a particular, what usage of this too. So what's the usage of this? Wait, let me write. The whole numbers are basically used for measurement. Measurements. Right, the whole numbers are basically used for measurements. Then we have whole number. Whole number we have discussed. Now we have decimal numbers. How many total decimal number we have? Let me write that too. We have total decimal numbers which are equal to 9. Not 9, however 10. So we have basically total 10 decimal numbers. How they are 10? Alright, let me count. The decimal number start with 0. Alright, 0 is also a decimal number. 0, 1, 2, 3, and up to 9. Alright, so from 0 to 9 all numbers are decimal numbers. So from 0 to 9, if we count the numbers, it gives us the counting of 10. So basically 0 to 9 all numbers are decimal numbers. Now let's go with rational and irrational number. What's the concept of rational as well as irrational number? Let's go with that now. Initially I am going with rational numbers. Alright, so rational number. Rational numbers. Rational numbers are basically terminating or recurring. Wait, let me write that. Okay, they are basically, they can either be terminating decimal numbers or they can be recurring decimal numbers. Recurring decimal numbers. Alright, if they will be terminating decimal numbers, they will be rational numbers, and if they are not terminating, however they are recurring decimal numbers, they will be also considered as rational numbers. Alright, for example, if I have a number, like initially we should write the statement. Alright, there is basically P and Q where these both number belongs to integers in which Q is not equal to 0. Just because if Q will be equal to 0, this will go to infinity. Alright, and we don't have to take our answer to the infinity. And if P will be 0, so it will give us the number of 0 again, and 0 belongs to a rational number. So P upon Q belongs to integers, however Q is not equal to 0. Just because if Q will be equal to 0, it will give us infinity. Alright, so if I have an example, let's go with an example. We have 3 upon 5. Now let's divide this number. Alright, let's divide this. Now we know that inside the radical, inside a divisor, we need to put numerator first. So the numerator here we have is 3 and 5 we need to put here. So we know that 3 does not come in the table of 5. So we need to put a point and we need to make write here the 0. So now we know that 30 comes in the table of 5. 5 6 are 30. So 6 here, 30, and it gives us the remainder of 0. Now means what we have this 0.6, which means this is what? This is terminating. We there is a simple concept of terminating decimal number. If you have 1, 2 or 3 digits after decimal point, it will be considered as terminating. However, if you have more than 3 or more than 4, that would not be considered as terminating. Alright, that would be considered as recurring. So this number is basically a terminating decimal number, just because there is a only digit after decimal point. If I do put here 0.625, that would be also a terminating number. Alright, so this is nothing but it is a terminating decimal number. Now let's discuss about the recurring. What does mean by this recurring? This recurring basically mean that repeating of numbers after a decimal point. For example, if I have 1 upon 3, for suppose if I have 1 upon 3. Now we know that numerator will be inside, so 1 is inside and 3 will be outside. We know that we have to put point and 0. Now 10 does not come in the multiple of 3, that's why we have to take less than 10. So less than 10 is 9, and 9 comes with 3. 3 3s are 9. So here 3, 9, again 1 is left, point we have already there, 0, 3 3s are 9, again 1, point is also all there already, so 0, 3 3s are 9, again 9, 1 is left. So here what it will give us the answer 0.333, and bar means it is showing that 3 is continuing. Alright, 3 is there 0.33333, and so on. Alright, so this is basically a recurring decimal number. How it is a recurring decimal number? Just because it has all the values same after a decimal point, 0.33333. So this is the same. Alright, that's why it is recurring. Recurring means repeating. So this is recurring decimal number. Decimal number. Alright, so this was the concept of terminating as well as recurring. Now, if you have a number which is basically terminating, if that number would be terminating, of course that would not be recurring. Alright, so if that number is terminating, so means that this number is a rational number. Alright, as like 0.6, we know that 0.6 is not a recurring decimal number, however it is a terminating decimal number, so it is a rational number. And if your number is recurring, of course that would not be terminating. Terminating means ending of the number, and that would not end, however there would be the repetition of the number after a decimal point. So recurring decimal number is also a rational number, either that is terminating or not, however that is recurring. So if your number is either terminating, that would be a rational number, or it is recurring, that would also be a rational number. So here I am mentioning rational numbers are either terminating or recurring. This is not possible. If they are terminating, they must be recurring. There is or between them. Either they would be terminating or recurring. So let me write here or. Rational number would be either terminating or recurring. Alright, now let's go towards irrational number. Then we will be discussing about the real numbers. Alright, now we have irrational numbers. Now we have irrational numbers. Again, in the irrational number, there is not a concept of or. There is a concept of and. Means if your number would be non-terminating, it has to be non-recurring as well. Let me write that. Your irrational number would be non-terminating, decimal number, as well as non-recurring decimal number. Non-recurring decimal number. So here we have an and between them. Alright. Your irrational number has to be non-terminating and non-recurring. If your number, if the value which is given to you is non-terminating decimal number and as well as non-recurring decimal number, then that value is known as irrational number. For example, wait, let me write an example here. We have 0.62517365 and so on. Now as you can see the value, this is non-terminating, alright, and this is non-terminating. We know that just because it is not ending after point, it is going so on, so it is non-terminating, we know that, as well as non-recurring. Alright, just because after point you can see not any digit is repeating, 62517365 there is not any digit which is recurring. Alright, so it is non-terminating as well as non-recurring, and if your value is non-terminating as well as non-recurring, that is the irrational number. Again, repeating, rational numbers are either terminating or recurring. Irrational numbers are non-terminating as well as non-recurring. So these are basically irrational numbers. So now let's go towards real number. Now what are real number? Now I hope irrational and rational concept both are clear to you. Now let's go with real number. Then I'll be making a flowchart here. Okay, let's go with real number. Real numbers are nothing. Real numbers basically are the union of rational and irrational. The set of real number, which is basically represented by R, and it is the set of, let me write here, it is basically a set of rational which are denoted by Q, union, the set of rational union irrational, which means Q dash. Irrational numbers are denoted by Q dash. So real number is basically the union of rational as well as irrational number. Now I hope this is clear to you. What are real number? Let me highlight this too. Now let's make a flow chart. Alright, let's make a flow chart here. Okay, so initially we have real number. Real number is a superset. Alright, let me write this too. It is a superset, which means everything comes under real number. After real number, you know what real number is basically a combination of rational as well as irrational number. So let's write this. Rational numbers means rational numbers are the subset of real number, as well as irrational numbers are the subset of real number as well. So irrational number. Then as you can see, from the rational number we have whole numbers. We have whole numbers. Basically I should put here integers. It would be more good for me. Alright. Integers are basically nothing. These are denoted by capital Z, and what comes under integers is 0, plus minus 1, plus minus 2, plus minus 3, and so on. Alright, these are basically integers. From integers we have the set of, you know what, we have the set of whole numbers. Whole numbers which are represented by capital W and starts with 0, 0, 1, 2, 3 and so on. Then we have, you know what, whole number is a superset of natural number. Means natural number is a subset of whole number. Natural numbers, which basically are represented by capital N and starts with 0, 1, 2 and so on. Then we have artificial numbers like even number, odd number, composite number and prime number. So this is basically the classification of number system. So in next video we will be going with complex number. We will be discussing that what are complex number, with that the 4 operations which are used in the complex number. This was all for today.